Hey, welcome to another Ivy Maths Made Easy video. This one's about probability. It's chapter 10 of the Haese Mathematics SL core book if you need any questions or anything. And yeah, let's get into it. So most of this course is focused around experimental probability, which is basically finding the probability of something from doing an experiment. So say you roll a dice 20 times, 6 times it lands on a 2. So you'd say there's a 6 out of 20 chance of rolling a 2. That's basically the experimental probability. And the way you represent that is just in a fraction. So in the example that I said, it was 6 out of 20, which is 3 over 10. You can show it as a fraction. If you want to, you can do decimal, so you could do 0.3. But yeah, that's how you show it. You'll often get questions like this, mind my writing, where you get a two-way table sort of, so child, adult, and whether they prefer grapes or apples. And so you'd find the probability for, say, the probability that a child likes grapes, that would be 7 over 20, because all of these numbers add up to 20. So 7 over 20, or you could say the probability that someone is an adult and likes apples. Then you could say 2 over 20, 1 over 10. Yeah. Other questions they might give you are testing if you know the difference between and or. So they might say, find the probability that someone is a child and they disliked it. So that would be 17 over 130. And then they might give you one there is, find the probability that someone is an adult or they disliked the ride. So you'd add up this one, and this one, which comes up to 75 over 130. So it's just understanding the difference between and or. Often a way that they'll show different outcomes of a thing. So in this case it's flipping a coin, you have heads and tails. So you can either have a 2D grid, so it's showing the 4 different outcomes, heads and then tails, heads and then heads, tails and tails, tails and heads. And then there's also a tree diagram, so it's heads, 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 tails, tails, heads, tails, tails. So these both show the same thing, but in just slightly different ways. So a formal definition of probability would be the number of times an event is occurred over the total events that have occurred. So if something happened 16 times out of 100, the probability is 16 over 100. And one other thing you need to know, so if you remember from set notation, that little apostrophe means not. So not A plus A has to equal 1. So 1 is the entire outcome of results. That's the whole spectrum. Now, often they'll ask you or incorporate a Venn diagram into a question about probability, and all you have to do then is use your knowledge from Venn diagrams and just read the values off of the Venn diagram. So if they ask you the probability that someone likes football and hockey, then you do 15 out of 30, 1 over 2. That's the probability. And say the probability that someone likes neither, 9 out of 30. So just reading the values off the Venn diagram. So this right here is the addition law of probability, and it states that the probability of A or B happening is equal to the probability of A happening plus the probability of B happening minus the probability of A and B happening. Now this might seem confusing, but if we look at it on a Venn diagram, it seems much simpler. So say football is A, hockey is B. So the probability of someone liking football is equal to 15 plus 4, right? And the probability of someone liking hockey is equal to 15 plus 2. If we just added them together, we'd get this 15 twice. So that's where this comes in. We subtract this 15 once, and what we get is 21. So 21 over 30 would be the final answer. If two events are mutually exclusive, meaning they don't have anything in common with each other, the addition law simply becomes PA plus PB. So say S is swimming. To find the probability that someone likes football or swimming, you just add up the probability that someone likes football and likes swimming, because they have nothing in common. So there's no problem with that. Another handy equation to know is the probability of A and B happening is equal to the probability of A times by the probability of B happening. This only works if the A and B are independent, which means they don't affect each other. So say you flipped a coin and rolled a dice, flipping the coin won't affect what you get when you roll the dice. So if you multiply those together, you get the probability of A and B. And you can use that in a tree diagram. So there's a 0.2 or 20% chance of raining, 80% chance of sunny, and we'll say, just for this, that if it was raining before, that has no impact on the weather of tomorrow. So we can do 0.2 times 0.2 for raining, that becomes 0.04, which is 4%. So 16%, 60%, 64%. So we're just multiplying the two probabilities to find the probability of each outcome. Now, if the two events are dependent, so say for example, if you have a bag with 10 balls of different colours, if you pull out a ball that is yellow, then you can't pull out that same ball. So the probability of the second event depends on the probability of the first event. That means it's dependent. So the probability of A and B happening, if something is dependent, is the probability of A multiplied the probability of B given that A has happened. And that's what that little line means. That means B given A, and we'll look into that. So on a tree diagram, say we have 6 balls in a bag, 4 of them are red, 2 of them are yellow. So if we pick out a ball without replacing it, that means the events are dependent, because the first ball that you take out will affect the probability of which second ball you take out. So 4 out of 6 are taking red, and then 3 out of 5, because one of the 4 has been taken, which means there's only 5 balls left, but there's only 3 red balls left. So 3 out of 5, then 2 out of 5 for the yellow, because there's still 2. And basically, you just add it up, thinking through it each time. And then say we want to find the probability that they're both red, so red and red, which follows this law. So we do probability of red times the probability of the second one being red. But this one is already in this form because we already have subtracted the first red ball. So all we need to do is multiply 4 over 6 and 3 over 5. That gives us 2 over 5. Now say we wanted to do red then yellow. That would be 4 over 15, because we're doing 4 over 6 times 2 over 5. So when we were looking at the formula for dependent events, we saw this probability of B given A. So it's different, A given B is just easier to write. So we're going to find out how to find out what's the probability of A given B. So probability of A given B, this line in the middle means given, so A given B, so given that B has already happened. That is equal to the probability of A and B happening over the probability of B happening. And that's all you need to remember, really. And here's a little formula to find out whether events are independent or dependent. If they are independent, the probability of A and B happening is equal to the probability of A happening times the probability of B happening. That's just like a formal equation that you can use. And if you think through it, it makes sense, because dependent, it would affect it, which means you need to do the B given A, and yeah, it just makes sense. One useful thing we can do with probability and probability of something happening is predict or try to predict future events. So say there's a goalkeeper that saves 7 out of 10 penalties that he faces. If he faced 50 penalties, how many would he save? Well, we can do that. We just have to multiply these two and we get 35. So if he faced 50 penalties, we can predict that he would save 35. And that's everything for chapter 10, probability. Thank you for watching. Make sure you do plenty of practice problems in your textbooks, the practice problems that your teacher gives you, because that's the most important thing. You only know you know something once you've proved that you've done it, and that's through doing questions. So make sure you do plenty of questions. Thank you for watching. Hope this helped you.